So good evening all. I hope you all are doing well. So as a part of Super 6 Basics, till now we have completed. So there are three important Super 6 Basics we have just covered. So in that Super 6 Basics, one is how to learn atomic numbers in the simplest manner we have discussed, and also how to learn atomic masses 1 to 30 elements along with the simplest shortcut. Simple electronic configuration. There are three important basics which we have just covered along with the simple shortcuts and clear explanation, and also with the simple tips and tricks. In this class we are going to discuss about one of the most important concept, orbital electronic configuration. This orbital electronic configuration is going to play the vital role in most of the chapters. In that chapters, especially inorganic chemistry, so every chapter of that inorganic chemistry is interlinked with the orbital electronic configuration, and also in some other parts of physical chemistry and organic chemistry also, some specific areas we are going to have orbital electronic configurations. So let us see. So these 1 to 30 elements orbital electronic configurations with a simple trick, so which you have to just learn with a little bit careful observation. Okay, before we learn simple electronic configuration or orbital electronic configuration, so we need to learn there are two important rules are there. One is the octet rule, so that is the octet rule which we have to learn, and second one is the duplet rule. So octet rule or the duplet rule, if you want to understand, so first we have to know that so why this octet rule and the duplet rule came into picture. One is, so now we know that there are 118 elements are present in the entire periodic table till now, which elements we are knowing. So then in that 118 elements, there are 8 elements which we are having, the 7 elements, so which we are having highest stability. So those stability of those elements, when we looked at that particular, we know that valence shell is going to play. From the previous classes we have seen that valence shell is going to decide the chemical properties of the element and also properties of the element. So now when we are saying these 7 elements, if they are highly stable, so why these 7 elements are highly stable? So definitely we are going to see their outermost electronic configuration. Then we found interesting, there are two important interesting facts we have just identified. Out of 7 element, one element is having 2 electrons with only one shell in its valence shell. So only one shell, and remaining electrons are having more than one shell and 8 electrons. The common property between all these remaining 6 elements are, so those are the different, along with the oganesson is also there, the new element which is the 118th element. This oganesson is also having 8 electrons. So these all 8 electrons. Now we come to a conclusion that it means if any element, if it wants to be a stable, it has to follow two important rules. One is either duplet rule if it is having only one shell, and second one is if it is having more than one shell, then it has to follow octet rule. So when this octet rule is going to be applicable, if it is having more than one shell, if it is having more than one shell. So these are the two important factors which we have to remember. After that, so as we are saying, then this is the orbital electronic configuration. So then this orbital electronic configuration, whatever this orbital electronic configuration, so if you just look at, so what do you mean by the orbital? First we have to know what is the orbital. So now orbital is nothing but, you have to note down this point carefully, three-dimensional space around the nucleus. So where maximum number of electrons, where the maximum probability to find the electron is present. What do you mean by this? So this is three-dimensional space around the nucleus where maximum probability of finding electron is present. It means it is some imaginary space around the nucleus. So those types of spaces are, there are four different types of spaces are present. Some of the orbitals, they are having the spherical shape. Some of the orbitals are having the dumbbell shape. Some of the orbitals, they are having the double dumbbell shape, and some of the orbitals are having the complex shape. And this spherical is like, named it as the s orbital. This dumbbell is named as p orbital, and this double dumbbell is d orbital, and the complex is f orbital. So definitely we are going to have. So why do we call these orbitals with these letters only? So to understand this, one of the most interesting fact and also one of the most interesting aspect we have to know. So let us see what it is. So now in this case, generally to identify some unknown compounds molecular formula or to unknown samples, we use generally spectroscopy. And this spectroscopy, whatever the spectroscopy is there, even to identify the some of the different types of the then elements, then especially their shapes also, there are four different types of the then we are having the four different types of the signals we are going to get. So in that, the first one is, there are some fundamental signals will be there, principal signals also will be there. There are some diffused signals also will be there, sharp signals also they will be there. So these spherical orbitals are giving the sharp signals, that's why it is called as the then s orbital. These diffused double dumbbells, they are giving the diffused signals, that's why it is called as the d orbital. And this dumbbell signals dumbbell orbital shaped orbitals are giving the principal signals, that's why it is called as p. And the complex orbitals are giving the fundamental signal, that's why it is called as the f orbitals. That's why in the previous slide I have just mentioned. So s stands for sharp, d stands for diffused, p stands for principal, f stands for fundamental. So now we got to know that why these orbitals are named like this. Now as I said, it is the spherical, there is only one type, and the principal, again there are then there is a one type of the spherical. Again the principal orbitals or the p orbitals, again three types are present. S orbital, there is only one type. D orbital is 5 types, and F orbitals we are having the 7 types. So why do they present these many ways, and what are the major reasons? Then let us see in the next slide. So now we know that, so if you want to see that why these orbitals are having means, in the previous slide as I mentioned very clearly, so there are some four types of signals are there. So one is the fundamental signals are there, and diffused signals are there, principal signals are there, and sharp signals are there. So now we got to know that till this point we used to think, so only atom is having, inside the atom there are only shells are there. But when after confirming from the simple electronic configuration, so 19th element, as it is not following 2n square formula, now we identified there are some, actually atoms are not present in the shells, they are present in some orbitals. Now one more question is arised here, even orbitals also, within the same orbital also, elements are having some different properties. So when these are having the different properties, the same signals, they have started looking with the high resolution spectroscopy, and they have identified some interesting facts. The sharp signals are similar even with the high resolution spectroscopy, but the principal signal, it's not a single signal, it is a combination of three small signals. And diffused is a combination of five small signals, and fundamental is a combination of 7 small signals. It means even the orbitals are divided into some suborbitals. So that's why s orbital is having the only one suborbital, p orbital is having the three suborbitals, and d orbital is having the 5 suborbitals, and f orbital is having the 7 suborbitals. So now one more value we have to see, that in the last class we have just discussed n plus L value. Once again I am just reiterating here itself. So what are the L values? So for the L value for the no, orbital angular momentum for the SPDF orbitals, S is having 1, P is having S is having 0, P is having 1, D is 2, F is having the 3, and D, F, T, then the remaining. Mostly we are going to use, these are the 4. So G is having the 4, then that is we are going to see that. It means there are 1 suborbital in S, 3 P suborbitals, 5 D suborbitals, 7 F suborbitals are there. So now the question is, when it comes to that, before we see the quantum numbers or the orbital angular momentum for the SPDF orbitals, so then there are, like, what happened, we have identified these are the shells. Now we'll come to that. In each suborbital, how many electrons we can fill. In this case we are having, so in each suborbital we know that electron is revolving around the nucleus. So when it is revolving around the nucleus, it also revolves around itself. So when it is revolving around itself, there are two possibilities are there. Either it can rotate in clockwise direction, or it can rotate in anti-clockwise direction. If I consider, if element is rotating in one direction, we know that charged particles, when they are in the movement, then they generate some spin. If I consider there is a half spin is generated due to one direction, then obviously the opposite direction will give with the same amount of amount with the opposite direction. It means if one element is with the clockwise direction, another element with the anti-clockwise direction, they have the same amount of the magnitude with the opposite charge. So both get cancelled each other, then the suborbital will be stable. So now we used to fill suborbitals with two half arrow marks, upward arrow mark and downward arrow mark. Upward and downwards they indicate one direction with half of charge. It means each suborbital is having 2 electrons. So as we know that S orbital is having only one suborbital, P orbital is having the 3 suborbitals, and D orbital is having the 5 suborbitals, and F orbital is having the 7 suborbitals. So when they have the 7 suborbitals, it means here I can fill 2, here I can fill the 6, here I can fill the 10. So means 1 into 2 electrons. Here 3 suborbitals means 6 electrons. 5 suborbitals means each one 2 2, it means 10. 7 suborbitals means it is equal to 14. So now we got to know that S capacity is 2, P capacity is 6, D capacity is 10, and F capacity is 14. So after this, so these are the different orbitals and their shapes we have just discussed already. SPDF L values again I have just given here, and these are the different N plus L values. This is one of the most important rule for this N plus L value. So if you want to know the N plus L value, why? Because we got to know that right now how many, if we know that in each suborbital, like in this particular case there are shells, like as we got to know that there are 4 orbitals we have identified in the atom. So now the question number 1, out of these 4, how many of them they are present in the first shell, in the second shell, third shell and fourth shell? For this, the answer is number of types of orbitals equal to shell number. It means in the first shell we are having only one type, that is S. That's why it is called as 1s. Second shell, 2 types, S also, P also, that is 2s, 2p. Third shell, three orbitals, s orbital, p orbital and d orbital. It means 3s, 3p, 3d. Now the fourth shell is having four types of orbitals: 4s, 4p, 4d, 4f. So it means when electron is having, so when in that first shell, as we are having only one orbital, there is no problem with the electron directly will enter into 1s. But in the second shell we are having two options. Third shell we are having the three options. Fourth shell we are having the four options. So then in that case, so four options are present, and in that case the electron, where this electron has to enter. To identify this, we use this n plus L value. It means not only shell, we are supposed to consider orbital number also, orbital also. This shell is represented with n value. Orbital is nothing but orbital angular momentum is represented with L value. After calculating, we know that L is nothing but what? For s orbital it is 0. In the last slide we have seen p is equal to 1, d is equal to 2, f is equal to 3. So for this, if you want to calculate for 1s, n value is 1, L value is 0, that is 1 plus 0 is 1, 2 is nothing but 2, and it is L value, as we know that S value, L value is nothing but it is 0, 2, like that. So we have just calculated all of them, but there are some places where these values are same. So why these values are same means, if those two values are same, then what we are supposed to do? If both the n plus L values are same, then first we consider n value. So that is one of the important. If lowest shell will be filled first. So now in this 2p also 3s, both are having the 3 and 3, but we are filling 2p first. Why? Because lowest n value. And one of the interesting fact, when it comes to the 4s and 3d, when it comes to the 4s and 3d, actually this is fourth shell and it is the third shell, but the n plus L value of 3d is 5, but 4s is only 4. That's why we fill this 4s first, then this 3d we fill later. It's one of the most important point in understanding of that n plus L value. So then when you arrange all the elements in the, then increasing order of their energy, nothing but increasing order of their n plus L value, so that is called as Aufbau principle. So now the word Aufbau is nothing but, the German roots, and it means, then it is remembered as build up, or it may be a constructing the orbitals in the energy, increasing order of their energy levels. First we fill 1s, then after 2s, then 2p, 3s, 3p, 4s, 3d, 4p, 4s, like that till the 8s orbitals we are going to fill. This is also one of the most important, what is the Aufbau principle. Then after Hund's rule is also there. This Hund's rule is saying that, so when you are filling, when more than one suborbital is present, for example in the, so p orbital there are three suborbitals are there. So then in that case all three, for example I am taking the 2p. So 2p is nothing but what? As 2p, same n plus L value is present. Same n plus L value is nothing but, so these all orbitals, suborbitals, they are having same n plus L value. That's why these type of orbitals are called as degenerated orbitals. Degenerated orbitals. These degenerated orbitals are supposed to give equal priority. It means you need to fill first 1 electron with the 1 suborbital, then you need to pair up with the remaining electrons. That is called as the, so then Hund's rule with the same spin. Now Pauli's exclusion principle. Next rule, most important rule, is Pauli's exclusion principle. It is saying that no two electrons in the same suborbitals can have same set of four quantum numbers. Same set of four quantum numbers. So now you need to remember this point. We are going to work on this again. Same set of 4 quantum numbers means, so one quantum number, one is the, yes, n is the one quantum number, L is the another quantum number, M is the another quantum number, S is nothing but one quantum number. N is saying about in which shell orbital electrons is present. L is saying about in which orbital electron is present. M is saying in which suborbital electron is present. So, but S is saying in which direction it is revolving. What is the spin of the electrons? For example, if I am just taking this particular 2s. So now 2s, so both electrons are belongs to n is equal to, both electrons are belongs to L is equal to 0. Both electrons are also belongs to, that is whatever the electrons, m value also is from minus L to plus L. So in this case minus L to plus L means both of them the m value is also a 0. Now but when it comes to the spin, last S value, one electron is having the plus value, another electron is having the minus value. So even if they are having three quantum numbers are same, but the last quantum number, that is spin quantum number, is not same. Why? Because in every suborbital electrons are present. One is in the clockwise direction, second one is the anti-clockwise direction. That's why Pauli's exclusion principle is saying here, no two electrons are having a same set of 4 quantum numbers. With this, so then to fill the electrons, so there is a proper series to fill the 1 to 30 elements. So till this particular series is more than sufficient. All the electrons of the each and every elements starts with 1s because its n plus L value is equal to lowest, ends with till so 3d. Why? Because its n plus L value is the highest. So every time, one simple example if you want to see it here. So here we fill the n orbital number, whatever the orbital number you are just saying, nl. So then power is x. Here n is indicating shell number and L is indicating the subshell number and x is indicating number of electrons. But to remember, so we need to remember S capacity is 2, P capacity is 6 and D capacity is 10 and F capacity is 14. Let us take one example and see the list of all 30 elements. For example 12. So 12, it is magnesium. Its number of electrons like 12. So first out of 12 electrons we need to start with 1s in the first shell s orbital. We know that capacity of s orbital is 2. It means you have to write 2 electrons. Out of 12, 2 I have filled here. I left with 10 electrons. Remaining electrons will go to 2s. Here s capacity, always s capacity is only 2. Again in this s also I can fill maximum 2. I left with 8 electrons. Then the next electron should enter into the P. We have to know that what is its capacity of the P. The capacity of P is equal to 6. Means I have more than 6. So that I can fill 6 electrons comfortably. Always you need to count the then whatever the powers are there, are they equal to 12 or more than 12. If it is more than 12, you can't fill more than 12. If it is less than 12, you can shift to the next orbital. Till now I have filled 10 electrons, 2 more electrons are left, so I can shift. After completing 1s, so I have shifted to the 2s. After completing 2s completely, I have shifted to the 2p. Then as I have more than that also, after completing 2p, I am going to fill 3s. So that is 3s power 2. That is the 2s. Now count all of them, it is equal to 12. So this is the orbital electronic configuration. By using this simple series, by remembering these maximum capacities, you are able to fill all 30 elements very comfortably. So that we have to just see that. And in this case we know that second shell is completely filled, third shell is not yet filled, means still here So the all first shell is totally filled, second shell is totally filled. All together it is equal to 10. It means up to 10 as it is stable, I can write it as, instead of writing whole thing, I can write it as neon 3s2. This is called as outermost orbital electronic configuration. Till where electron or atom is stable, so till then you will write as a nearest inert gas. The remaining electronic configuration you are supposed to write as it is. This is called as the outermost orbital electronic configuration. So these are the 30 elements. By using the outermost orbital electronic configuration, you can try all of them so very comfortably. And after that, as I have discussed right now, so orbital, like then the first shell, so quantum numbers n, l, m, s, as I mentioned right now. So what are the different possible quantum numbers? You have to remember one of the most important point here. N is equal to nothing but it is the shell number, it is independent. L value is depending on the n. Why? Because it is from 0 to n minus 1. Remember it very clearly. M is depending on the L value. It is from minus L to plus L including 0. And S values are nothing but plus or minus half. So these all, I think in this class we have discussed one of the most important concept. So what are the orbital electronic configuration? What do you mean by the octet rule? What do you mean by the duplet rule? So why do we follow them according to the inert gases? And what are the different types of orbitals are present? Definition of the orbital. And why do we represent them with the SPDF only according to the spectrochemistry? And also how many suborbitals are there? What is the capacity of the each and every suborbital? And what is n plus L value to fill the electrons we have to follow, and how we are supposed to write all of them so in a order properly. I hope so this you might have understood it very clear. To get the same concept in life with me, so and also to get these kind of videos, please subscribe my channel and share it to the as many as needy people in rural and other areas, tier 1, tier 2 cities. If you want me catch in live and to get either one-to-one classes or the live sessions, you can join in my academy, so with the lowest affordable payment and also with the highest quality. So thank you very much all of you for following me continuously and showing your lot of love and affection towards my academy. Thank you one and all. Have a nice day.